Hello and welcome to this section of the Ti-89 calculator tutor, and in this section we're going to tackle the topic of graphing polar equations, or graphing equations in polar form is another way to say that. Basically in this video series we've learned how to graph regular functions on the calculator, we've learned how to graph parametric equations in the last section, and here we're going to learn how to graph the polar equations, which is when you have a function of theta, or a function of the angle. So we're going to start where we did the last time. We need to go in the mode menu first and realize that our graph mode is currently set to function. Those are regular old f of x functions. We need to change it to a polar function, polar representation. All right. The other thing to note is that we are currently in radian mode. That means that when we think about our polar equations and how when we start tracing them and things like that, all of the angles are going to be in terms of radians. So if that bothers you, then you can go ahead and change it to degrees. Just something for you to be aware of, okay? Now, when we go into the y equals menu, instead of y1 equals something, y2 equals something, y3 equals something, we have a little different representation. r1 is a function of theta, r2 is a function of theta, so on. So each one of these guys is a different function of theta you can type in. You can graph multiple plots here just like you can graph multiple functions. And so when you type in your expression, when you type it in, it has to be a function of theta because that's what a polar equation is. So every independent variable that you type in has to be theta, which is in green on the calculator. So just to kind of recap, when you're doing regular old functions, way back when we first learned how to graph on this calculator, normally you type the x button, f of x. When we did the parametric equations, they were functions of time, so we had to use the t button. Now that we're dealing with polar equations, and they're functions of the angle, we have to use the theta button, so the green angle here. So just for the purposes of illustration, let me go ahead and just type a equation in here. So we could have sine of theta, green, and then the theta button. Let me close it out and we can square it. Now you can have very, very complicated polar equations. That's fine. For right now I'm just going to type mine as sine squared of theta. I'm just going to have one of these guys. Alright, and by and large your knowledge of how to plot on this calculator that we have obtained earlier in the course is basically going to translate directly into what we're doing here. So all of the different general ideas about the graphing menu, the plot styles, things like that, they're all going to carry over from what we've learned before. So right now we're going to kind of go in with a laser focus into the things that make the polar representation a little bit unique. Okay, so we've got the polar function typed in. Let's go off and take a look at the window menu in this mode and see what it has. Now, it's going to have some sort of default values here. Your calculator might have something different. But don't forget we're in radian mode. So it's going to have a theta min, theta max, and theta step. This is basically what angle do we start at. So this is 0 radians. This is what angle do we end at. This is 6.28, which if you think about it is 2 pi radians. So 2 pi radians is one complete circle. So basically we're going to only graph one complete circle. If we change this to more than this number, then it'll kind of continue to go around after one full circle as many radians as we tell it. It picks some default theta step here. If you lower this number, your graph will take a little bit longer to draw, but maybe slightly more accurate because you're taking finer and finer steps. If you make theta step much bigger, then it'll graph faster, but maybe it will look a little chunky because you're taking larger steps in theta. My advice is, at least in the beginning, just sort of leave it alone and see what your graph looks like, and you can always zoom in or zoom out and kind of fiddle with this. X min, X max is just the window viewing in terms of X, minus 10 to 10. Y is minus 10 to 10. Basically, the zoom controls are going to take care of this as well. All right, so let's go ahead and take a look at what our graph looks like and just kind of go from there. So go green button, graph. Let's go take a look at the graph screen. It says it's busy. And notice in the very center of the screen, we've got something here. Now, it's kind of hard to read, so my advice is go to zoom menu, zoom in. It's going to ask us for the new center. We're already on the center, so let's just go ahead and zoom straight on in. We could do a box, but we can do this as well. Let's zoom in one more time. We'll zoom in right there. See what happens. Now we're kind of off the screen. All right. So at this time, it might be good for you to do a zoom fit. Zoom fit like this. All right, so we'll back out a little bit here. It recalculates. Now notice that everything is a little bit squished. You know, these guys are a little bit squished, and we talked about that earlier before. A lot of times the curved equations, when you graph them here, if you don't adjust everything properly, if they're circular, they look a little bit squished. And it doesn't really matter, but if that bothers you, you can go to Zoom Trig, and the calculator will try to automatically adjust everything so that things look a little bit nicer. And in this case, we still need to zoom in a little bit. So that looks a little bit nicer than the squished mode. It's very important for you to know, though, that this graph here is not any different than it was just a few minutes ago. It's just that we have adjusted. See how the tick marks are a little different along X, and the tick marks are a little bit squished along Y? Well, it adjusts that for you to make the graph look a little bit prettier, but the values are all really the same no matter how you zoom in on the calculator. Okay, so here you have your graph. This is a polar equation, a polar graph. It's easiest to explain how this works if we start to trace. So you can trace these polar plots just like you can trace any guy, F3. So let's hit F3, and you'll see that we have a blinking cursor here. And what it's telling us here is the current location of this cursor is at theta, which is the angle, is equal to 0 radians. And at that angle, X and Y correspond to 0. And this information comes from the plot that we typed in, the equation that we typed in. It types this guy in there, and then it calculates the corresponding X and Y value. As we go to the right, you see how my cursor is starting to move up. Well, here we're at an angle of 0.52 radians, right? So if you think about how the angle is sweeping up from the x-axis, in radians, we're going to get up here. Eventually, at the top of the y-axis, we're going to be at pi over 2 radians. So here we're almost halfway between those 2 points, and at that point we have calculated based on our value of our equation. Let's go back and look at our equation. We said r is equal to sine squared theta. R is the distance from the origin. So don't forget, in polar form, you're not plotting x and y really. You're looking at the angle as you go around the coordinate plane, and at every angle you calculate r, the distance from the origin. And so you plot the at the angle that you're at, you basically put a distance r away from the origin that you've calculated. So at this point, at this angle of 0.52, when you take the sine and then square it, you're a distance of this far away from the origin. Now in this particular mode, the calculator has sort of converted that into an XY format, but which is nice, it's fine if you want to convert the location of this graph to XY format. But since we're in polar form, this is not that useful. Usually we want to see R and we want to see theta. So let's go and fix that. Go into the Tools menu, go up one to Format. All right. Here, this is basically graph formats. This is like, okay, rectangular, we're graphing the graph sequentially, we want grid axis on, or off I should say, or a grid off. We do want the axes on. There's a lot of things here. We've talked about this graph format menu before. What we want to do is take it out of rectangular and put it into polar. And this means when it says coordinates, this means when we trace it, it's not going to give us XY, which is rectangular. It's going to give us polar representation. And that makes sense if you're in a polar mode. So let's hit F3 again. Notice that things look a little bit different now. Now there's no X and Y anywhere. We're just given R and theta. So basically, as I go around and as the angle increases, I'm now presented with R, the distance from the origin. So let's kind of start over a little bit and see how this works out. When theta is very small, the radius is very small because sine squared is small. As the angle increases, this radius from the origin gets larger and larger, and that's why the point moves out farther and farther away. So I'm getting farther and farther away as my angle increases. Now I'm getting close to pi over 2 right here on the axis, right, which is pi over 2 radians, and the radius is 1. That's because sine squared pi over 2 is 1. As I continue to go around, my angle has now gone past pi over 2. My radius starts being pulled in, and that's because of the sine function. Eventually, when I get down here to 3.01, remember this is not degrees, this is radians. So when I get over to basically pi radians, my radius comes back in. When I go past pi radians, down here, see I'm sweeping at an arc. I'm sweeping at an arc, starting at an angle over here in the x-axis and going around over here. When I get to this angle over here, my radius begins to increase again, and basically I come all the way around full circle. So the way you need to kind of think about these polar graphs is you really need to think about a line sweeping out. I'm starting on the x-axis. My angle is increasing. What is the radius? What is the radius? What is the radius? Is it going in? Is it going out? Is the radius going in? Is it going out? That's all going to be determined by the function you have. And so that's why polar equations can generate these beautiful graphs that look like a flower or look like a lazy 8 or something like that. It's because basically you're looking at the angle as you go around and you're plotting against that the radius from the origin. So that's all stuff you really should have learned in your class, and just try to give you a little bit of a primer as you do these things. So just to recap, if you go off into the window menu, the theta min is the smallest angle that we're starting with. Theta max is how far we're going in terms of angle. This is 2 pi, one complete circle. This is the angle step. X min and X max and X and Y min and Y max, these are all just defining the window viewing area that we're really looking at. Okay. One more thing I will tell you is that if you go out of here and go back into the mode menu, let's go back into the mode menu here and let's take it out of radians for some reason. If you'd like to look at this in degree mode, then if we go back to the graph menu, it'll start to plot this guy. Now, the deal is that your window, see, nothing actually happened. You might say, well, what's going on here? That's because all the settings that we were using were set up from the radian mode. So we're only graphing from 0 to 6 degrees. Now, this is all in terms of degrees. So you would need to change this to 360 degrees, let's say. And let's do it in 1 degree increments. And for X min, X max, I mean, we could just do it -2 to 2. We could do -1 to 1. Let's see what this looks like. So we'll give it a second. We'll start to see some activity here. Here we go up with our graph. But, by and large, the graph really should look the same, because if you're graphing in degrees or radians, basically all you're doing is the same thing in either case. You're looking at the angle sweeping up and the radius, which is the distance from the origin at that angle. So here's another angle. The distance is a little bit larger. Here's a steeper angle. The distance is a little bit larger. We get to the vertical axis here, pi over 2, which is 90 degrees. And then we have a maximum. And so as we continue sweeping around, that sign is basically going to chop it off depending on the angle that you're at. And when you trace in this mode, now you're given degrees, basically. So here, when we say theta, this is 4 degrees, 5 degrees, 6 degrees. You can type something in. What if you wanted 25 degrees? It'll skip to 25 degrees. What if you wanted 97 degrees? Type 97 in. It'll go over there. So when you're tracing on this calculator in any mode, really, you can type in whatever value you want and it'll skip over to that point. So that's really handy. All right. The zoom modes, by and large, work basically exactly the same way that we've talked about previously in the course. So I don't really feel the need to go through all of these again. If you want a box, you can hit this guy and zoom in on an area. You can zoom in and out. You've got some specialized modes here, but the bottom line is you just kind of fiddle with it and zoom in and out until you get the graph to look the way that you want, so you can trace and see the whole thing at the same time. All right. You can also create a table of values, which can be handy. We can go to table set here. This all behaves just like what we've done before. If you want a automatic table to be generated, you fill the top part in. We'll start at 0 degrees with an increment of 1 degrees. We'll turn this off for now. We'll talk about that later, and we'll leave it in auto mode. So everything's basically the same. So we'll go over to the table screen, and here we have a table of values generated starting at 0 degrees, 1 degree, 2 degree, 3 degree, and it calculates the value of the radius. So you can see how the calculator is arriving at this plot, because it's basically increasing the angle and calculating the radius, and it's basically plotting those two things. All right, if you go back to table set, sometimes it's handy to take this guy. We can go ahead and leave this the same just for comparison purposes. If you take it out of auto and put it into ask mode, then ask means that basically you're going to be able to type in numbers here as well. So what if we wanted to do 2.25? We can type it in and we get a value back. And then what if we wanted 3.27? Then it'll give us a value back. So again, just like in the other modes, it's handy if you need to create a table of values and you don't want to continually calculate it by hand. Just define an equation for it, go into the table here and type in the values that you need, and then you can get the guys exactly the way you might need there. Get the whole table of values. And then finally, take it out of auto here. If you go up here to graph table and turn this on, just like in the other modes, basically it's going to generate this. It's going to generate this table exactly based on the way the graph is drawn. So right now we're actually drawing the graph with an increment of 1 degree starting at 0, so this is why the table looks the way it does. Finally, you can do the split screen modes. This has all been covered before, but just to briefly tell you, if you go to page 2, split screen is currently in full mode. You can go, for instance, left to right and define your two guys. Table, we don't want home, we want table and graph usually, right? And so here's the table of values. To switch to the graph mode, just go and hit this little icon right here. Blue over here, you've switched here. Now it says busy, it's graphing our polar guy here. And basically you can look at the graph, you can trace it, you can look at the values, you can fiddle with it at the same time that you can look at the table. So it's handy if you ever have a need to do that. It's not something that you're going to be doing every day, but it's something that can be useful to do. So we'll go ahead and wait for the graph to continue to plot here and then finish talking about the capabilities of graphing in polar mode. Alright, so let me go ahead and get out of the split screen mode. So we'll go over here, F2, and we'll take it back to full mode. Okay, so here we are back in the table. We can go back and look at the graph. Now, it's going to think again for a second and plot. The polar mode of the calculator has some mathematical abilities, F5. We've talked about a lot, basically all of them before, so it's going to be pretty quick to go in and chit-chat about what they do. But basically you have the ability to take on-screen derivatives, find the slope of a tangent line at a given point, all while you're looking at the graph screen. So it is kind of handy to do. We've talked about these modes in the regular graphing section of functions. We've talked about most of these modes in the parametric section. So go to F5 and let's take a look. Value really is not that useful because you can do this in trace mode. When you do value, basically it's basically asking you what value of theta do you want. So go ahead and type in 0.5 or what about 1.27 or something like that. And then the cursor will snap to that angle and it will tell you that radius. You can do that exactly in trace mode. We've already done that, so that's not that terribly useful. But what is useful is to come down here to derivatives. Notice a lot of these things are grayed out. They're just not available when we're in polar graphing mode. But if we look at the derivatives, we have the ability to take, let's go down and talk about this first, dr d theta, the rate of change of the radius with respect to theta. And it's going to ask us for, for a location. So I can trace along the graph to get where I want to go, but if this is taking too long, I can just simply type in 29, for instance. The cursor will snap there and it'll tell me the derivative of the radius. How fast is this radius changing as I sweep around in theta? This is what the value is equal to, and it'll show you that there. Okay. You also have the capability of looking at dy dx, which is a little bit confusing when you're in polar mode. But don't forget, the calculator is plotting on a rectangular grid, even though it's presenting a polar plot to you. So for some odd reason, if you ever wanted to convert these coordinates, r and theta, if you wanted to convert them all to x, y, and then look at how y was changing with respect to x, you could certainly do that. But you're almost never going to use this in polar mode, so it's kind of silly to actually have it here, honestly. But the calculator does give you that ability. When you're taking a derivative in polar mode, you're going to be interested in dr d theta, usually. All right, down below we have distance. This is basically the straight line distance between 2 points. So we'll hit enter for the first point here. We'll go over here to the other side of the curve so you can kind of see what it's doing here. Notice what's happening. You see how we have a line draw between these two guys? So we hit enter again. It's telling me the distance between these 2 points, the straight line distance between these 2 points. For some odd reason, if you needed to find the distance between 2 points on a curve, the straight line distance, you could certainly find that there. Okay, let me go to F5 and go down here. Let's go and take a look at the arc. That's a little bit easier to explain. Now the next guy here, this is the arc length. So this could be the first point. Second point, let me type in at 170 degrees. So I can type in a value, hit enter. So it's thinking for a second, and this guy is telling you the distance between 2 points, but along the path of the function, along the arc, in other words. So from point A to point B in terms of an arc right here. And so in this distance between these 2 points on the curve, between down here and over down here, which is almost like 170 degrees or so, the arc length, the distance along the path here, along the function that I've defined, is given right there. And the arc length is defined in terms of calculus. You do an integral to actually figure it out, but the calculator can do that for you. We've talked about that in the past. And finally, you can find the line tangent to the curve. So if we go over here to, let's do like 50 degrees. You can type a value in if you like. So at 50 degrees, it's going to think for a second. It's going to calculate a line tangent to this point. It's going to draw the line tangent to this point, and it's going to write an equation for us. This is the slope of the line tangent, which is in front of x. This is the y-intercept, and it's sort of plotted it for us here. So if you're drawing lines tangent to curves, it is very handy to do. Now, we did fly through all of those features and functions. The reason we flew through them is because we've covered them all before. We've covered them all in the regular graphing mode. We've covered them in the parametric mode. By now, I hope you understand that once you know how to use the calculator, once you know how the calculator operates, then doing all of these functions in the different modes really is the same thing. There's really not a lot different between the different modes, but you do have to understand, obviously, what a polar equation is, and what a parametric equation is, and what a regular function is. So make sure you know how to graph these polar guys. It is something that you'll definitely use in school. It is something that you'll definitely be tested on, and it'd be a shame for you not to know how to graph these guys so that you can check your work, because a lot of times when you're graphing these polar equations, it's very difficult to visualize what it's going to look like. You know, as pretty as this guy is, it's a relatively simple polar equation. When you type something more complicated in, you know, they can look quite beautiful, but very difficult to predict in your mind what they're going to look like. So make sure you understand how to use the calculator to its fullest potential.